So I was saying that the last time that we met, we ended with an assignment, and that assignment was for you to read about, to just draw for me the symbol and give me the use of all of these ones here. The first one was a variable resistor. The second one was a thermistor, an LDR. This is 1, this is 2, this is 3. Then we had a relay, this was 4. And then we had a diode, this was 5. And then, yeah, that's what I told you to read about. And I gave you the page from our course book. So in case you haven't done so, please try to go through that work again, find some time and read about those, because when I come there next time, I'll be asking for my work for marking. So try to go through that again. Now, this term, we are left with, which I want to cover before January ends. We want to look at digital electronics, but this one will come later. Let me first share with you what I want to cover first. I want us to look at the last bit, the last block, block 5. It is kind of short and very simple. So this is what we're going to begin with today. We're going to be looking at modern physics, but we shall be looking at only the part called atomic physics at our year 11 level. So we shall be looking at the nuclear atom, and I hope that by the end of the lesson we shall be done with this. Then we shall be looking at radioactivity. This is where we find things like half-life, things like beta particles, alpha particles, and so on. And that is all in block 5. So hopefully, by next Monday, we shall be done with block 5 by next Monday. So what we're going to be looking at today is the first part called atomic physics. This is what we'll be looking at. Now, when you're done with this, we shall go back and pick up from where we left. And that is from digital electronics. We shall look at the digital electronics. Then after that, we shall go to the dangers of electricity. And then we go to electromagnetic effects. I hope that you're seeing what is on the screen, guys. Are we seeing what is on the screen? Yes. Okay.
Yeah.
So the AC generator, the transformer. Then we have the last part called, actually that is the last part. Electromagnetic effects. The magnetic effect of current, force on a current, the DC motor, that will be the last part. So like I've said, I'm beginning with block 5, and that is atomic physics. This is where I want us to begin with, such that by Monday next week, we're done with it, then go back and pick up what was left in block 4. So that is what I wanted us to see before we begin. Now, we shall be doing at least one test every week. I need to put that in the plan, whether it is done at the auntie's place, whether it is done as a research work. I'll be doing one assignment, one assessment, one test every week. So prepare for that as well. Whether it is 2 numbers, no problem. So remember, we have limited time that we have to cover everything. And at the same time, we have to be testing ourselves because we're nearing examinations. Okay, let's start with this atomic physics. Excuse me.
The
Yes. What is it all about? Atomic physics. What is an atom? What do you remember about atoms in chemistry? I know you looked at this in chemistry.
is the smallest indivisible particle.
Which takes part in a chemical reaction. Okay, that is
Yes.
very good. That is very good. Anything that you know about an atom? Yes, Sunil? Sunil, yes, please. Okay.
So is it can only be divided by chemical means?
By chemical means, it is the smallest indivisible particle which takes part in a chemical reaction. That is by definition. What components do you remember about the atom? What are the parts of the atom? What do you remember?
Nuclear.
That is correct. Speak louder. It has the nucleus. Anything else?
What about the protons and the
Protons and electrons.
There are protons and the neutrons. Okay, that is correct. Anything else?
electron?
What about them? It also has electrons. It also has electrons. That is correct. That is true. Yeah. So, how are the electrons? Where do you find the protons, the neutrons, the electrons? Where do you find them according to what you have learned in chemistry?
In the atom. When you see the parts of the atom, that's where you find it.
Okay. Okay. Let's watch this short video here, and then we shall proceed from there. Share sound. Let me play this.
Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe the basic structure of atoms. You should then be able to state the radius of an atom and the nucleus, and finally you should be able to describe how the electron arrangement may change when radiation is absorbed or emitted. Now I should point out that this topic does overlap with chemistry, so if you've already watched my chemistry videos, then a lot of this will be familiar. However, there are some details specific to physics, so you still need to make sure that you learn this. Okay, let's start by looking at the basic structure of an atom. I'm showing you a picture of an atom here. Now the first thing to notice is that atoms are very small. They've got a radius of around 1 × 10⁻⁻⁻10 meters, and you need to learn that. Now this is an approximate figure as some atoms are larger than others. Atoms contain a central region called the nucleus, and the radius of the nucleus is less than 1/10,000th the radius of the atom. In other words, the nucleus is tiny compared with the atom. However, almost all of the mass of the atom is concentrated in the nucleus. So let's look at that in more detail. The nucleus contains two particles. These are protons, which have got a positive charge, and neutrons, which have got no charge. They're neutral. So what that means is that the nucleus has an overall positive charge, and that's due to the protons. Now the nucleus is surrounded by electrons, and these have got a negative charge. We find electrons in energy levels, and energy levels are at different distances from the nucleus. Now there is one key idea about energy levels that you do need to understand. Energy levels which are further from the nucleus are at a higher energy than those which are closer to the nucleus. So this energy level is at a relatively low energy as it's closer to the nucleus, whereas this energy level is at a relatively higher energy, and that's because it's further from the nucleus. Now electrons can change energy levels if they gain or lose energy, and we're going to look at that now. If the atom absorbs electromagnetic radiation, for example light, an electron can move from a lower energy level to a higher energy level, like this. Now, the atom can now emit electromagnetic radiation, and the electron returns back to the lower energy level like this. So as you can see, by absorbing or emitting electromagnetic radiation, electrons can change energy levels. Remember, you'll find plenty of questions on the structure of atoms in my revision workbook, and you can get that by clicking on the link above. Okay, so hopefully now you should be able to describe.
Okay, I think that is enough for now. That is about an atom. I know that we have covered in the video they have talked about somehow more things than we're supposed to be looking at this level, but at least we have an idea of what you've just been telling me, that an atom is very small. It is the smallest invisible particle which takes part in a chemical reaction, but we don't need that in our physics. All we need to know in physics is that an atom is a very small particle. That's what we need to know about an atom. And then two, that an atom is made up of basically three things. One, the nucleus, which has both the neutrons and the protons. And then two, the shells, which they have called the energy levels. Now, we shall not use the word energy levels at this time. We shall call them the shells or the orbits. That is what we shall be calling them at the moment. And then number three, that an atom has protons which are positively charged, and then has electrons which are negatively charged. Let me share with you this again, and then we do take some notes about this. I hope that you can see something on the screen.
Yes, sir.
Okay, atomic structure. I'm going to tell you what to write down. I will be sending you this maybe later on, but I'm going to be telling you what to write down as we're discussing. So, an atomic structure, we're saying that an atom consists of a small central nucleus composed of protons and neutrons. That is what you've said. And this is how it looks like. When you draw it on a piece of paper in 2 dimensions, it is simply, these shells here are simply made up of, these are what you call the shells or the orbits. Let me get another pen here. The shells or the orbits. That's the name that we give them. The shells or the orbits. Now in 3D, this is how they look like in actual sense. But when you're drawing them, simply draw them like this. And then in the center, this is one circle. In the center, have the nucleus. And then around this, we have the electrons. Now, I just want you to write the heading in your book, block 5, and write atomic physics. Block 5, and then write atomic physics. And then after that, write a subheading, structure of an atom. Are we together? Are you done? Structure of an atom. And then you draw for me what I'm drawing here. You draw for me what I'm drawing here. Then we have this one as an electron, like that. So these are electrons. And then this, the whole of this is what we call the nucleus. And then this is what we call the proton. We're just trying to write down a summary of what we've just talked about. This is a proton, and then this is a neutron. This is, in brackets, positive. This one is a negative. And then this one has no charge. So when you're done, you let me know. When you're done doing that, you let me know, then we proceed. Yes,
Yes, sir.
okay, that is nice. So I was saying that
I'm also done.
I'm sorry. Okay, yes, okay. So all I was saying that what you need to remember about this is the structure. How does the atom look like? Now, of course, what we are seeing on the diagram here is that the central part is what we call the nucleus. So they will ask you that what is made up of the nucleus? What is making up the nucleus? There are two things. One, the protons, which are positively charged, and then the neutrons, which are not charged. They have no net charge. Then the electrons are always moving around the nucleus. They're always moving around the nucleus, just like you're seeing on those black circles there in the 3D diagram. They're always moving around the nucleus, and the electrons are negatively charged. So I've got my first question here, that what is the difference between, or differentiate between electrons and neutrons? Electrons are negatively charged, protons are positively charged. Electrons are found, that is not where they're found. Electrons are found on the shells of the atom or the orbits of the atom, and then protons are found in the nucleus of the atom. Later on, we shall be talking about radioactivity, and we shall be talking about specifically the nucleus of the atom. Now, someone may wonder that if it is the smallest indivisible particle which takes part in a chemical reaction, we cannot see it using our naked eyes. Then how do we conclude that the protons are found in the nucleus? How do we tell that the electrons are found on the shells? And by the way, how do we tell that the protons are positively charged? The electrons are negatively charged, and then the protons are positively charged. How do we tell that? Is someone having an idea from chemistry? Someone can share with us what you learned in chemistry. Okay, let me share this. We have the Rutherford's model of the atom. We have what called the Rutherford's model of the atom. In other words, Rutherford is a scientist who did great studies about the nature or the structure of the atom. And of course, other scientists also came along and contributed on this. For example, the Neil Bohr, but of course, we don't need to know about that at this level. But all we need to know is that we have a scientist called Rutherford. So what
cryptocurrency, where fortunes can be made overnight. And 2021 is the...
Let me first share the sound. I know you're not hearing the sound properly. Let me share it again. Okay, share sound, all right. So let's watch this video, then afterwards I'll be asking you some questions as well concerning this.
The plum pudding model of an atom was one of the most widely accepted models all over the world for understanding the structure of the atom. However, several experiments performed by scientists to study the atomic structure showed astonishingly different results. They were contradicting the plum pudding model. This led many scientists all over the globe to reconsider the structure of an atom and study it again. Around the year 1911, a British physicist, Ernst Rutherford, carried out the famous gold foil experiment. He did this to understand the structure of an atom. The experiment was carried out by Rutherford along with Hans Geiger and Ernest Marsden. The experiment he performed was a breakthrough in the field of chemistry, which helped him understand the structure of an atom in a more accurate manner. This is how the setup of his experiment looked like. As we can see here, he used a source of alpha particles locked in a lead container with a very small slit. This ensured that the alpha particles only came out through a small opening and travelled in a straight line.
Okay, later on we shall be looking at what alpha particles are, but what we need to know at the moment is that alpha particles are positively charged particles. They have a positive charge. That's what we need to know at this point. We'll be looking at it later on under radioactivity.
But why did he select alpha particles in the first place? Well, the alpha particles were having high energy and were heavier as well. So if we say the atom is like a pudding of positively charged particles with electrons embedded in it, then the particles will pass straight through it. This is obvious because the heavier particles will pierce through the lighter pudding structure of the atom and pass through it. This is what Rutherford thought. For this reason, their greater mass and energy compared to the protons made him choose alpha particles for the experiment. Next, he used a very thin gold foil on which the alpha particles would bombard. Why did he choose a gold foil? Well, a really thin gold foil was estimated to contain approximately 1000 atoms. Lesser the atoms, more convenient the experiment would be. Lastly, are we able to locate this circular band with a gap here? What could this be? Well, this is the screen, a fluorescent screen that would help us detect the radiation. That means the screen will glow or emit fluorescent light whenever alpha particles will hit it. So this is how the track of alpha particles can be traced. Now we're all set to understand how the experiment worked. The alpha particles were emitted from the element present in this box. These directly hit the gold foil. Now what should happen ideally? As we know, the Thomson's model suggested that an atom is a sphere of positive charge with negative electrons embedded inside it. That means it is expected that the alpha particles will pass right through the atoms and hit the detector straight.
So this is where my question is going to come from, and please be ready to answer that question. The question is that what are the observations made in the experiment? And then 2, what conclusions, what deductions do we make from this experiment? That is what is going to be my question. So prepare to answer that question there. In other words, what are the observations made in the experiment and what is the conclusion? All right, let's continue.
And why so? Because the mass of alpha particles is heavier than the mass of positive charges. That means they should directly hit the atom and move ahead through it. Only a very small deviation would probably be acceptable in this case. But is this what he observed? Not really. He was astonished to get unexpected results. What results did he get? He found that most of the fast-moving alpha particles passed straight through the foil and hit the detector. However, some particles got deflected by small angles. And lastly, to his astonishment, few alpha particles also rebounded. Now, how can this be possible? These 3 observations made Rutherford think that the plum pudding model is not really correct. Based on the conclusions he had, he put forward the new hypothesis explaining the structure of atoms. What were his conclusions? Let us have a look at the conclusions by Rutherford, followed by the new atomic model put forth by him in the next video. Gold foil experiment gave him interesting results. What results did he get, by the way? Let me recall them for you. He found that most of the fast-moving alpha particles passed straight through the foil and hit the detector. However, some particles got deflected by small angles. And lastly, to his astonishment, few alpha particles also rebounded. Now, how can this be possible? These 3 observations made Rutherford think that the plum pudding model is not really correct. Let us take a simplified example to understand the inferences first. Let us imagine that we have a ball made up of cotton. The cotton in the ball is very sparsely distributed and has an extremely tiny circle or sphere located at the center. This sphere is quite hard and dense. So hard that it can even resist a bullet shot against it. Now, what will happen if you shoot many bullets across this cotton ball? Most of them will travel straight through the cotton surface. What will happen if a bullet hits the edge of the central heavy mass? In this case, the bullet will slightly change their path and get deviated. So looking at the size of the central mass, it's obvious that only some of the bullets will get deviated. Lastly, what happens when a bullet hits the center directly? Needless to say, it will bounce back, because we know that the central dense mass is too hard for the bullet to pass through. So very few bullets will bounce back. This is analogous to what Rutherford had inferred about the atomic structure. His first conclusion was that most of the space inside an atom is empty. This is because most of the alpha particles could easily pass through the atoms and hit the detector straight. Now, if most of the space is empty inside an atom, then where is the positive charge located? Well, that's the second conclusion. The positive charge is compactly packed in a tiny entity. This occupies an extremely small space inside the atom. Now, why did he think so? Let's go back to our cotton ball and bullet example. Can you recall the second and the third case? Yes, the bullets get deviated on hitting the tiny sphere of the edge, and they will rebound when they hit the center. Same explanation holds true for this. A few alpha particles get deviated. That means there is a possibility that these hit the edge of the positive center. Yes, and one more possibility is that they get deviated because the positive center repels the alpha particles as they're also positively charged. Also, a very small number of alpha particles rebounded. That means there is a possibility that these alpha particles had directly hit the positive center. But since the number of these rebounding particles is too small, it explains that the volume occupied by the positive center is also very small. If the space occupied would have been big enough, then the number of alpha particles bouncing back would also be greater. So let's say there are gold particles in the foil. He found that most of the rays pass straight through the atoms. A few rays change their path and get deflected. Lastly, very few particles bounce back. These results compelled Rutherford to come up with a new nuclear model. Let's have a look at the hypothesis put forward by him. Firstly, there's a positively charged center in an atom called nucleus. Nearly all the mass of an atom resides in the nucleus. Secondly, the electrons revolve around the nucleus in circular paths. Thirdly, the size of the nucleus is very small compared to the size of an atom. However, theoretically, there were many flaws in the hypothesis. Let's have a look at the drawbacks in Rutherford's hypothesis in the next video. Also, we will have a look.
Okay, so we shall look at the hypothesis and its failures later on in year 13. At the moment, that is what we need to have with you at this level. So my question is, what are the observations made in the experiment? And then two, what are the conclusions in the experiment? Let's think of this in a while, and later we shall come back and actually we shall continue from there. But then before you do that, let's first write down something very small from where I have just stopped. Just talk about this, a small subheading. Rutherford's model of the atom. The pen is misbehaving here. Rutherford's model. Oops, let me just use this other one. Rutherford's model of the atom. Rutherford's model of the atom. So experimental observations. What did you observe? What were the observations? Sorry. Anyone who recalls, there were 3 observations made.
Particles were deflected.
Yes?
The particles were deflected.
How are they deflected? Very many, very few, none, all of them. I'm sorry. Okay, few alpha particles. Few alpha particles. Let's write this, please. Few alpha particles were deflected or were rebounded or turned back. The first one is that very many alpha particles passed through. Very many alpha particles. We have like around 2 minutes, so let be first. Very many alpha particles passed through the gold foil. This is actually very few. Very few alpha particles were deflected back. Then here we have few alpha particles. Alpha particles. Were reflected. Let's come back and meet from here. Let's have a break of 1 minute. Few alpha particles were reflected back. Sorry. Few alpha particles were reflected at different angles. That's what I wanted. Alpha particles were reflected at different angles. Let's come back after the break.